Hi guys, this is a video covering a wide range of materials that you need to be familiar with for your GCSE or A-Level DT exams. Luckily, materials is a topic that doesn't change too much once you get to A-Level, so the content overlaps between GCSE and A-Level. I've listed the material categories here that I'm going to talk about: physical versus working properties, woods, composites, metals, papers and boards, textiles, smart materials, and ending with polymers. Two disclaimers before I begin. Firstly, I'm a Year 13 student making this video, so if there are any mistakes or corrections, I'll list them in the description and the comment section of this video, though I've tried my best to fact check everything against textbooks, my notes, and the internet. Secondly, this video covers many exam boards, however not 100% of everything will be applicable to you, so have your specification or your revision list handy and check what materials you need to know for your exam. Okay, starting off with the difference between physical properties and working properties. So physical properties are the traits a material has before it is even used. Working properties are how a material behaves when it's manipulated, when there's force added to it or there's forces on it. So some examples include physical properties: density, which is basically the mass per volume of a material; the weight, how heavy something is; the moisture content, how much water is in the material, normally in woods; shrinkage, when materials when normally woods lose water, they shrink sometimes; thermal conductivity, electrical conductivity, so ability to conduct heat or an electric current; the grain, so the direction of like wood grain is a physical property; color, the aesthetics, the color of material; texture, transparency in normally papers and boards, to what extent light can pass through that material; chemical resistance and absorbency. Then we have working properties, so stuff like workability, which is how easy it is to cut, shape, finish, or even like carve that material; machinability, the ease of being processed using machines; stability, so a lot of manufactured boards are quite stable, they don't warp or twist easily; abrasion resistance, flexibility, tear resistance, grease resistance, so these are more in textiles or papers and boards; printability, so the ability to accept printed ink or images. Most papers and boards have good printability, so they can basically graphics can be printed on. Hardness, which is the resistance to scratching or indentation. So hardness is different to toughness. Um, Hardness is scratching, toughness is like shock, and other forces. So different types of strength as well: tensile strength, compressive strength; elasticity, the ability of a material to return to its original shape after being deformed; and permeability, malleability, ductility. These two ones are really common; and then weldability and moldability. So in exams, often you'll see questions like explain one working property of, or give two physical properties of. Um, Really common exam questions, and here are a list of physical properties and working properties. Okay, onto our first actual material, so timbers or woods. So there's hardwoods and softwoods. Hardwoods comes from broad-leafed deciduous trees, whereas softwoods come from coniferous trees, like Christmas trees. They have needle-like leaves. Softwoods are cheaper and faster growing because the trees grow faster. And then hardwoods come from sort of trees that have sort of bigger leaves. Okay, so there's 5 hardwoods which I've mentioned here: oak, mahogany, gelatone, beech, and balsa. So these directly correlate with the A-level NXL specification. And there's 4 softwoods: redwood, larch, pine, cedar. So starting off with oak. Oak is a hard material, which means it does not scratch easily. It's resistant to wear and tear, and it has an attractive grain. So this is a piece of oak furniture. It contains tannic acid, which will corrode steel fixings, so often it has to be finished so it does not end up corroding other metals. It is the strongest and densest hardwood. So densest means it has the greatest mass per volume. It's used in furniture, barrels, etc. Hardwoods tend to have a closer grain, which means they carve better because they're less likely to split or splinter. If you can imagine, softwoods have more basically holes in them, have more empty space, so they're likely to splinter, etc. Then mahogany has a dark red color. It's durable, stable. It's used in musical instruments, in cabinets, etc. Gelatong, a slightly different hardwood. It's got a softer texture, soft, spongy texture, and it's easy to work with hand tools. It has a low density and a lower durability compared to the other hardwoods. It's similar to balsa, actually. We'll talk about in a second, but has a tighter grain. So balsa is a super lightweight hardwood. People often think it's a softwood, but it's actually a hardwood. It has a straight grain, low density, lightweight. It's used in model making. So often in school, you would have seen this material in like model airplanes, model houses. For example, here is an example. of like an architecture model made with balsa. It's super soft. You can almost like you can carve it with your fingers. You can snap it. You can like squeeze it. Quite yeah, a low density material. Um, and yeah, it's actually a hardwood, even though it has sort of softness and it's a lightweight material. Okay, and then beech is the final hardwood I'm going to talk about. Has a straight grain with a fine uniform texture, making it easy to work with. It's used in mallets. It's used in children's toys. Used in chopping boards. Beech is yeah, quite a hard material, and it has a sort of slightly lighter color compared to oak and mahogany. So an acronym you can use to learn just the names of these hardwoods is BOMBJ, balsa, oak, beech, mahogany, gelitor. Okay, now to move on to softwoods. So redwood, larch pine, cedar are the four you need to know for specifically for A-level at Excel. So redwood looks like this, not so quite common. It's a lightweight material, but it has good strength. It's used in structural components and eternal decorative molding. So, for example, architraves. Larch is a hard, tough, waterproof material, but it's prone to splitting, so it needs to be pre-drilled. It's used in boat building, fences. Pine is a very common softwood. It has a straight grain. It's knotty, so quite you can see quite a common property of softwoods is that they're knotty, they have knots in them, um, and pine is susceptible to what? So it has to be finished. It's lightweight, low density, and used in sort of basic furniture and stores and so on, and used in construction. Then cedar is a quite interesting softwood. It has this slightly darker, richer color to it. It's got natural resistance to decay and insect infestation, which is why it's used in outdoor cladding, used in fences. Here you can see outdoor chairs made from cedar because it's naturally resistant to decay and rotting, etc. So 5 hardwoods, 4 softwoods. Um, Generic properties of timbers. So for example, hardness, as we said earlier, is the resistance to scratching. Workability, how easily it can be cut, shaped, carved. Strength, here you can see 5 different types of strength. Tension, compression, shear, torsion, bending. So in bending, there's tension on one side, compression on the other side. Okay, on to our next material, which is going to be composites. So we have some timber-based composites and some other sort of non-timber-based composites. So starting off with MDF, super common material, it has a smooth surface, it's dimensionally stable, so it's not likely to warp because it's man-made. It's highly susceptible to moisture damage, and it expands when it absorbs water. So yeah, MDF and water does not go well together. You have to finish it in some way to make it waterproof, to make it resistant to water. It's easily shaped and it takes paint well. It has a really sort of nice texture, so it absorbs paint really well. A misconception is that it's lightweight. It's very common in the exam to say, oh, material is lightweight. MDF actually is not lightweight. It's really dense. It's heavier than a lot of hardwoods as well. And it comes in large sheets, which most manufactured boards do. Um, Normally comes in 1.2 meter by 2.4 meter sheets. Then in plywood, which is similar to MDF, it has an odd number of layers, so it's made up in this layer form like this. The reason it has an odd number of layers is so the top and bottom grain direction is parallel. So three layers, 5 layers, etc. It's a strong and stable material, similar to MDF. It has a high strength to weight ratio, so it's relatively lightweight for how strong it is. It's used in furniture, cabinetry, a lot of different things. And plywood is probably the material you're most familiar with, using it in school. It's available in various thicknesses, so normally in multiples of 3, so 3, 6, 9, 12, etc. Comes in large sheets. Um, and this is what it looks like. So if you have to identify it based on a picture, this is what plywood looks like. It has these very visible layers. Then let's talk about blockboard. So blockboard is made from solid wood strips or blocks like this picture shows that are sandwiched in between thin layers of wood veneer. So relatively almost low quality material, but really strong and used in construction. Then hardboard is used in the back of wardrobe backing. So if you can imagine like having a freestanding wardrobe, the thin material at the back that's just there as a show, it just to yeah, to provide a backing. That's normally what hardboard is used in. It has a smooth surface and it's tough, even though, well, I guess in the wardrobes it's quite a thin material, so you wouldn't necessarily say it's tough. Then chipboard is the sort of third most popular, or like another manufactured board. It's strong in all directions. It's really strong. It's almost like MDF, but it's made in these chips, so larger chips. It looks like this. It's quite unattractive as such, but the manufacturing of it makes it really strong. It's not attractive at all. It's used in flat pack furniture with veneers. So a lot of like IKEA furniture is made from chipboard or even particle board, which is another type of chipboard. Comes in large sheets and it's available in various grades. So you have chipboard that's made for outdoor use. It's construction grade chipboard also exists, and it comes in various densities depending on what like purpose you're looking for. And then so those are what was that, 5 timber-based composites. Then we have 2 other ones. We have carbon fiber reinforced plastic and glass reinforced plastic, which are polymer-based composites. So carbon fiber and polyester resin gives you carbon fiber reinforced plastic. It's this material here. Um, it's lightweight, corrosion resistant, tough, has a low thermal expansion, and is quite a stiff material. It's used in cars. It's used in sports equipment, and it's made using the layup lamination process. So that's where you have sheets, or like matting is called, of carbon fiber. It's pressed into a mold, and then resin is poured on top to fill the spaces. And this, when the resin cures, this combination of having the fibers along with the resin, almost like paper mache, is what gives it that hard shell-like structure. And then glass reinforced plastic, similar thing, using glass fibers and polyester resin. It's lightweight, tough, it's an electrical insulator, it's transparent to radio waves, it's used in boats, in boat hulls, water tanks, and just like carbon fiber reinforced plastic, is made using the layup lamination process. Now to talk about metals, we have ferrous metals, non-ferrous metals, and alloys. So here we have 3 ferrous metals. A ferrous metal means it has iron in it. So this symbol in the periodic table for iron is Fe. That's where the word ferrous comes from. Ferrous metals are magnetic. They can rust and they contain iron. So mild steel, medium carbon steel, and cast iron are 3 types of ferrous metals. Basically, iron mixed with carbon. So mild steel has approximately 0.3% carbon in it. It's also called low carbon steel. It's ductile, has a high tensile strength. It's tough. It's malleable, but it has a poor poor resistance to corrosion. It's used in bolts, car bodies, and white goods. White goods are sort of appliances that normally have like a frame around it. So this, like washing machine, for example, the body itself, it would be made from low carbon steel, and the white comes from dip coating. So the reason it's dip coated is to protect it from rust, because otherwise the material itself, the mild steel, would rust. It's also mild steel is also used in like the polyprop chair, the legs of your sort of normal school chairs. And again, those are painted to protect against rust. Medium carbon steel has approximately 0.7% of carbon in it. It's harder than mild steel, but it's less ductile. It's malleable and it's tough. It's less malleable, but it's tougher. It's used in gardening tools, machine parts. A lot of like gears and bolts and stuff is what medium carbon steel is used in. And then lastly, cast iron is what your bench vices are made of, and like manhole covers. So it's got a hard outer skin. However, the core itself is really brittle. It's good under compression. So of course, a vice itself is used to create the compressive force. So yeah, cast iron good for compression. Um, so with all 3 of these, as you increase the carbon content, the strength and hardness increases, but it becomes more brittle. So brittle means it can't resist like a really strong, quick, impactful force. So if you smash like a vise with like a really strong hammer, it would probably shatter into like a load of pieces. So those are your 3 ferrous metals, and then we have up here 3 alloys. So alloy is a mixture of 2 or more metals. So basically normally to enhance properties. So brass, stainless steel, and beryllium. So brass is an alloy of 65% copper and 35% zinc. It's corrosion resistant. It's an electrical and thermal conductor. It casts well. It's hard, malleable, and ductile. Normally, as we've seen, if a metal is malleable, it's also ductile. And then malleable means it can be almost hammered or shaped without fracturing. And ductile means it can be pulled or stretched into some like almost like a string, or like a pipe. Like copper pipes are ductile because copper is a ductile material. It can be basically pulled into a wire. So here we have like almost washers or bolts or something that are made from brass. Stainless steel is tough, hard, corrosion resistant, smooth, non-porous. All metals are non-porous, so that it means it doesn't absorb water. It's easy to wipe normally. Made from chrome, nickel, silicon, manganese, and used in kitchenware, cutlery. A past question has been explain one property of stainless steel which makes it suitable for cutlery. So you can say it is corrosion resistant, which means that it will not rust. Therefore, it will be safe to use with food. So giving a point explanation and then linking it back to the question. So cutlery used with food, that's your 3 marks, a 3 mark question here. So that's stainless steel, and then beryllium is lightweight. It's a strong material. It's made from aluminium, copper, and magnesium. It's used in aircraft and vehicle parts. So those are 3 alloys. Then we have these 4 here, 4 non-ferrous metals, which do not rust, are not magnetic, and don't contain iron. So aluminium, copper, tin, zinc. Aluminium is lightweight, ductile, malleable. Aluminium is the one metal that for sure is lightweight. It's used in drink cans, aircraft bodies, bike frames. So, for example, here the bike frame made from aluminium. Copper is fatigue resistant, malleable, ductile. Again, we see malleable and ductile together. It's soft. It's used in wire, electrical wire, and water pipes. And yeah, because it's also a thermal conductor, so it can carry heat basically. And then tin is ductile, malleable, used in soft solder, so soldering, like welding is used in soft solder, used in circuit boards. It's a coating for food cans. And basically, yeah, it's used as a protective coating for steel as it does not rust. So if you think about like baked beans cans and stuff, normally sometimes covered in tin to stop the stainless steel from rusting. And then lastly, zinc has good corrosion resistance, used in buckets and a protective coating for other materials. So the big sort of street pipes or street lamps, they're often coated in zinc. It's called the process of galvanizing. It has that like almost that metallic finish to it. That's what steel does, and is also used in die casting. An acronym you may find helpful to remember these 4 non-ferrous metals is ACTZ, your aluminium, copper, tin, zinc. Now on to papers and boards. We have 4 types of paper and 6 different boards. So layout paper, starting from the thinnest, is thin, translucent, so it's used for transposing images, used in like architectural drawings. It's used in sketchpads, and it's around 50 grams per square meter, GSM. So GSM stands for grams per square meter. It is used to measure the mass of paper. So for example, 80 GSM means that 1 square meter of that paper weighs 80 grams. Next up, tracing paper is slightly thicker than layout paper. It's used for copying images when drawing or seeing an image underneath. So in maths, for example, you'd use tracing paper, you would have used tracing paper. It's 60 to 90 GSM. Then copier paper is inexpensive, general purpose. It can be colored. So this is your standard A4 or printer paper. It's used for general office printing. It's around 80 GSM. Then cartridge paper is the heaviest. It's off-white with a slight texture. It's used for sketching. So this sketchpad, for example, has 50 sheets of 140 GSM, so that would be cartridge paper. It's between 120 to 150 GSM. Those are your 4 types of paper, going from the lightest to the heaviest. Then onto boards, we have mounting board. It's made from compressed cotton fibers. It's used for picture mounting or modeling. And then corrugated board, which is just your normal cardboard. It's made from carton board outer layers and a corrugated middle layer. So this has the 2 sort of thinner layers of card on the outside. And then this fluting is the main thing that gives its strength, because although the fluting can be compressed downwards, it's strong upwards because of all the ridges it has. So this would be, so cardboard is strong in one direction, weak in the other. It's used in protective packaging as it's able to provide protection against impact. So like when you're moving house, or the boxes and stuff made from corrugated board. Then folding box board is made from multiple layers of pulp. The top layer is pigmented, it has good printability, and it can be embossed. So this picture here shows embossing, where there's like a difference in layers, difference in texture. So this process is called embossing, and folding box board is used in packaging. Then foil line board is used in the food and drinks industry. It is a board with foil applied to provide water resistance. It's used in drinks packaging and milk cartons. Then solid white board is a high quality card which is smooth on both sides, which makes it good for printing. It's used in greeting cards and packaging. So for example, this here is just a plain greeting card made from solid white board. Then foam board. Lastly, foam board has a foam middle core with 2 outer layers of card, and it's used in presentation boards. So, a past exam question has been explain two working properties of solid whiteboard that make it an ideal material from which to make a children's toy that has moving parts. So, because it's explained two properties, it's going to be a 4-mark question, and it's working properties, not physical properties. So, solid whiteboard is rigid, which means that it will not be easily damaged by repeated use. That would give you 2 marks. And then solid whiteboard has a smooth surface, which means that it will glide smoothly with little friction. In this case, being the context of a children's toy that has moving parts. Continuing with textiles, we have natural fibers and man-made fibers. So cotton, linen, and nylon. So cotton, linen, and wool are all natural fibers. Cotton comes from the cotton plant. It has high absorbency, so it dyes easily, so dyes different colors easily. It's got high breathability, so it's good for clothing worn next to the skin, and it resists static charge. Cotton is used for towels, bedding, clothing. So these sorts of towels are usually made from 100% cotton. Linen is made from flax fibers. It has similar properties to cotton, so it's durable, lightweight. However, it has a crispier texture and it's stiffer than cotton, which is why it's used in suits. And it has a higher wrinkle resistance. So linen is used in suits and elegant clothing because of its crispiness. So cotton is too soft for this, and it's used in home furnishings. So for example, this suit made from linen. Specifically with textiles, it's important to know examples of where the material is used. So you can think about properties. You can think about cotton being able to absorb water because towels are good for absorbing water. Then wool is made from the fleece of sheep. It has high warmth but low durability. A key property of wool, different to the other two natural fibers, is that it's inherently flame resistant, so it does not catch fire easily, and it has self-extinguishing properties. So therefore, it's a safe choice in environments where being able to catch on fire or like fire safety is a concern. So those three are natural fibers. General properties amongst all three of these natural fibers is they're all breathable, so they have good breathability. They are absorbent, have high absorbency, and are biodegradable. Then we have a couple of non or man-made textiles. So polypropylene is used in sportswear. So for example, like football shirts, because it's quick drying and lightweight. It draws sweat from the skin, from your skin to the surface of the fabric, so then it can evaporate quickly, which is an advantage of this material. Then nylon is not absorbent, it's durable, has high elasticity, it has high tear resistance, and it's breathable. It's used as an industry fabric as it's very strong. An exam question in the past has been give 2 reasons why nylon may be considered an unsustainable fiber because it's made from finite resources, and it will not biodegrade, therefore it's not sustainable. And then polyester is incredibly durable and retains shape over time. It's crease resistant, so it's used in trousers, shorts, jackets. For example, like waterproof jackets is made from polyester. And then some common textile properties, tensile strength. So the three man-made fibers, nylon, polyester, and polypropylene, have high tensile strength. Elasticity, wool, nylon, polyester, polypropylene. Absorbency, the three natural fibers. And then crease resistance, the three man-made fibers. And then another part that comes up in the A-level, I think only, is textile treatments. So Proban is a fire retardancy chemical, which is used to delay the spread of fire or the speed of spreading of fire. PTFE forms a thin protective layer on fabric surface, preventing stains from penetrating fibers, so it's for stain resistance. And finally, water resistance, coating coating the fibers with a chemical to reduce the absorbency, and it's used in outdoor products where, for example, rain can get absorbed in the textiles. We have two more material categories left. This is small materials. A small material is when a stimulus, which is a change in environment, so for example, change in heat, light, electric current, causes a change in material properties. So thermoceramics are a mixture of metallic powder and ceramic powder that's compacted into a mold and formed by heating up the mold and applying pressure. So here, a change in temperature causes a change in thermal properties, which allows for efficient temperature regulation. Properties of thermoceramics are they are incredibly hard and stable at high temperatures, used in automotive parts, drill bit tips, metal cutting tools. They're called cermets. So an example is tungsten carbide. So here is a tungsten carbide drill bit that can withstand higher temperatures without losing hardness, which makes them ideal for drilling through hard metals as they won't dull from heat generated. So normal high-speed steel drill bits will dull from drilling through metals that have a high melting temperature. Then we can talk about shape memory alloys, which is probably the most common smart material. Here, an external stimulus causes the metal alloy to return to its original shape. So, for example, nitinol wire in braces, which returns to its original shape due to the warm temperature in the mouth. So, it starts off having like a straight shape, for example, just a straight wire at low temperature, then it's deformed at that low temperature. Then in the mouth, when it's heated, it reverts back to its original temperature over time, and that's a cycle of shape memory alloys. Then we can talk about thermochromic and photochromic pigments. So if something has thermo in its name, it's to do with heat, and then photo is to do with light. So a thermochromic pigment, a change in temperature causes a change in color. Simple as that. So a use is color changing marks to indicate temperature for children or for vulnerable people, and using thermometers as well. Then photochromic pigment, similar to thermochromic pigment, a change in light intensity causes a change in color. So, for example, in welding goggles, if the spark from the welding causes a lot of light, the goggles can immediately switch to a darker color to try and block out that light. Then LCDs, liquid crystal displays, and electrical voltage causes liquid crystals to change from light to dark. So here they're used in screens, TV screens, calculator screens, etc. Then quantum tunneling composites, QTCs. Here, a change in pressure or strain causes a change in electrical conductivity. So used in touchscreens and pressure sensors. And then lastly, reactive glass. A change in external stimuli causes glass to change tint. So used in windows, where, for example, like big windows in offices and stuff can switch to like dark tint to block out, to basically stop them from being transparent. These are not used in welding goggles because they don't go fully opaque, they're just tinted. In welding goggles, you want the lens to go completely opaque. Lastly, and probably most interestingly, we have polymers or plastics. So there's two broad categories of polymers. We have thermoplastics and thermosets. So thermoplastic is where the polymer can be repeatedly reheated and reshaped. So here is an example of, or the diagram of a thermoplastic. So there's no cross links in between the different lines. And then thermosets, they can't be reheated and reshaped. Once they're cured, they can't be reshaped. So here they have cross links in between each of the different layers, the different strands, which means they're locked in, they can't be reshaped. So a lot of examples of thermoplastics and then a couple of thermosets. So first of all, acrylic is a thermoplastic. It's tough, hard, has good chemical resistance. It's translucent or sometimes transparent, and it's used in car light casings, line bending. So here's example of line bending. A sheet of acrylic is heated at those points there and then bent in that shape. And then also acrylic is used in bathtubs. Then ABS is used in rigid suitcases because it's tough and it's used in casings. So here's an example of a suitcase made from ABS. You can clearly see that ABS and a lot of these plastics can be pigmented, can be colored. So that's one advantage. It does not need to be painted on top. The material itself can be pigmented. So ABS, acrylic, thermoplastics. Then let's continue with more thermoplastics. LDPE, low density polyethylene, I think it's called, has a low level of rigidity. It's used in plastic wrapping and disposable shopping bags. PET has a high tensile strength and used in detergent or shampoo bottles. For example, this one here. Polypropylene is used in flimsy ring binders, and one unique property of polypropylene is that it has good fatigue resistance. So if you can imagine these ring binders here, it's all made from one sheet of polypropylene, and it's bent, and there's two like hinges there that forms the hinges, and it has good fatigue resistance. It can be opened and closed many times without tearing, without breaking. Then PVC is another thermoplastic, flexible, has good chemical resistance, as most of these plastics do because they're non-porous, used in flexible hose pipes, book protectors. So if you have any sort of exercise book or even black books in the library, they have that plastic cover on them, normally PVC, so that you can tell, in the exam, you can picture that material and think, okay, what properties does PVC have? And then PVC is used in food grade vacuum formed trays. UPVC is opaque, has good weathering resistance, it's rigid, it's used in these pipes, window frames, doors. So this here is UPVC. Um, and then, okay, lastly, HDPE, high density polyethylene, is weatherproof, translucent, transparent, used in plastic bottles. It's great for blow molding, so the process of blow molding, used to make bottles, plastic bottles, etc. And then HDPE is used in toys and buckets. So those, I think, are all of the thermoplastics. Then we have here four thermosets, and then 3 elastomers or 2 elastomers. So urea formaldehyde is hard, heat resistant, is a good electrical insulator, is brittle, used in domestic electrical equipment. For example, plug sockets here is an example of urea formaldehyde used in plug sockets. Most/all thermosets are brittle. That's one property across all the different thermosets. So polyester resin is rigid, is heat resistant, but it's brittle. So heat resistance comes from the fact that they can't be reheated. So if it's heated, it won't melt, basically, which makes it heat resistant, but it's still brittle. And then it's used in the layup process for glass reinforced plastic and carbon fiber reinforced plastic, as I talked about in the composite section. And then epoxy resin is rigid, clear, hard, tough, used for casting, so filling a mold, and encapsulation, which is how surfboards are made. Lastly, melamine formaldehyde. So both of these words have formaldehyde and resin are those keywords for thermosets. So melamine formaldehyde is a good electrical insulator. It's hard, it's stable. It's commonly used in laminate countertops. So the top surface of some kitchen countertops that aren't made from like granite or like actual made from stone. The top layer is going to be melamine formaldehyde, and the inside, the middle layer, is probably going to be chipboard. And then lastly, we have 2 elastomers. So an elastomer is a material which at room temperature can be deformed under pressure and then returns to its original shape. So basically, it's elastic. So natural rubber has high tensile strength, low elongation, so it doesn't stretch that much. Has good hardness, it's an electrical insulator, has good cold resistance, and this is the rubber used in tires and balloons. And then we have neoprene, which is similar. It's tough, has good oil and chemical resistance, it's abrasion resistant, and it's used in wetsuits. So those are all the materials in this video. Hopefully useful for everyone. If there's any questions or if there's anything you want to add, leave it in the comments. Good luck for your exams.